All right. Hello to my honors geometry class. Thank you to my sub who is playing this video for you. In order to be successful with this lesson, you are going to need to get out your packets. You're also going to need a compass. So if you don't have one, you may borrow one of mine. Please be very careful. I do not want to hear the zippy zippies, or I don't want my sub to hear the zippy zippies. You are breaking the compasses. Please squeeze the two little pieces gently together and slide to make that your point move. We shouldn't hear zipping. All right, if you can't handle it, we can take them away. So thank you for being respectful. All right, so progress check date is Tuesday, June 4th, just so you can kind of look ahead. Our next formative is going to be this Friday on May 17th. You need a straight edge and a compass today, so if you haven't gotten those, let's get those. All right. So what would I need you to do is recall how to perform a perpendicular bisector and an angle bisector. How about how to construct, not perform. Find a blank space in your packet and practice those constructions. So in order to do a perpendicular bisector, you need to start with a line segment. So create a line segment, just any random line, and we want to bisect in a perpendicular fashion. So basically what we're going to do is we're going to find one distance. We're going to make an arc. We're going to go over here to this side, put our point down, make another arc. And where those two arcs intersect, we are going to, sorry, mine's very, very sketchy. You're going to connect those 2 points. And then you have bisected. Not only did you bisect, it's also perpendicular, right? Okay, so I'll show you some resources for these if you've forgotten how to do those. In an angle bisector, you're going to put your point here. You're going to make one arc. You're going to come put your point here. You're going to make an arc in here. It doesn't matter if it's the same distance. You can leave it the same. Put your point here, make an arc there. And wherever they intersect, that also with the vertex is going to bisect that angle. So this and this, those two arcs. That whole arc, or the angle, has been cut in half. Okay, so those are the constructions we're going to need for the next couple days. This is the one we're going to explore today, and tomorrow we'll work more with that when I am back. Okay, so tonight's homework is page 54 to 56 in your packet. I really don't want you working on that yet, so those of you that like to work ahead, please do the activity with us in class. Thank you. All right, so some quick notes. This is in your packet. These are different points of concurrency in triangles. So when you're talking about a circle and you find the center of the circle, there's only one center of that circle. All right, but when you're talking about a triangle, it's kind of like the center of the triangle, but notice there's lots of different. There's one option here, one's there, and one's there, and they're all different places. Some of them coincide if it's a special kind of triangle. I have a couple videos to show you. It's kind of cool. But if we do a perpendicular bisector on all three sides, if we use a perpendicular bisector, the point of concurrency we're going to get, it's called the circumcenter. And what that means is that is the center that is equidistant from each of these vertices, which means I can circumscribe, meaning draw a circle around the outside, right? If that's my radius, that distance is my radius, I can swoop it around. That is the center of the circle that connects all of the vertices. I'm sorry, the circle, all the vertices lie on the circle. Okay, so the circumcenter is equidistant from each vertex of the triangle. That's really important. It is the intersection of the three perpendicular bisectors of the triangle. And this is the one we're going to focus on today. All right, but let's just write our notes for the other ones. So an angle bisector, which we'll look at more tomorrow, if we bisect all the angles, we will find the incenter. And the incenter is the center if I inscribe a circle. So if I draw this circle here, inscribed, that's the center of that circle. So here, it's equidistant from all the sides, right? The radius, it's equidistant from the sides of the triangle. All right, so here, the circle is inside. Here, circle meaning around. If you circumvent something, you've gone around. So this is outside. The circle is outside. Outside circle. And this is an inside circle. All right. And here the incenter is equidistant from each side of the triangle. That's important to the side, not the vertex. It is the intersection of the three angle bisectors of the triangle. Okay. Great. So there's a couple more. When we do a median, we're slicing the side in half. Notice it's different than a perpendicular bisector. Here we bisected, but notice this is perpendicular. It's not going to the vertex. Whereas here, it sliced the side in half, but it goes up to the vertex. So if we have three of these medians, what we're finding is the centroid. The centroid is the intersection of the three medians of the triangle. And lastly, we have the altitudes. So if we drop an altitude, it's 90 degrees, but it does not bisect the side. So here we have 90 degrees, but not bisected, 90 degrees. All right, we drop an altitude. That is called the orthocenter. The orthocenter is the intersection of the three altitudes of the triangle. So if you notice, these two are useful in some situations, but these are most useful just because of the circle that can inscribe or circumscribe. All right. Hopefully that was enough time to write your notes down. All right, so we're going to do it. Make sure your pencils are sharpened, you're ready to go. We can hit pause. Actually, let me stall for a minute. I'm going to show you some resources that you have available. So in your MyMCPS, when you're at home, or if the sub is okay with you using your phone as a resource, you could have this going if you have the app. So if you have the MyMCPS Canvas app, you can go in and access this, right? You can go down, and here I have construction videos. So what I like about these, you may have seen this resource in the past. I posted it for my students. It gives me all sorts of links. Copy a line segment, distant perpendicular bisector of a line segment, angle bisect of an angle. Okay, so today we're going to do perpendicular bisector of a line segment. So I'm going to click on that. Let me adjust this screen so I can see it better. Okay, so what I like to do is hit options and auto repeat. So it just keeps going over and over. So if it goes too fast, I can just wait for the next round to go. So then I'm going to hit run. So it starts at the line segment. It shows that my compass needs to be more than 50% of the way. It makes an arc. Now it's okay to do an arc up and down or all the way through, either way. Here we go to the other side, same. You can't change the distance of the compass in between going from P to Q. Find those 2 points and connect them. Okay, so then it just loops and it keeps playing that over and over. So if constructions was a point of weakness maybe for you at the beginning of the year, this might be a good resource to have playing to keep reminding you what the steps are. Okay? All right. Another way to do it is, it says place the compass tool point at one end of the line. Next, it adjusts the compass. Here. It tells you what the steps are. Adjust the compass to just over half the line length. So if you put it on the loop, it doesn't tell you all the steps. But this is a great resource. All right. Cool. So please use that. Maybe practice at home. All right, let's go back. Okay. So triangle centers. Our goal for today is to construct the circumcenter of a triangle to circumscribe a circle about a triangle. My goal, I'm just going to do a really rough sketch. I want a circle. Woo! That's a really bad circle. Okay, we're going to be able to do it much better than that. So I want to get a circle so that it goes through all three of my vertices. So I need to find the center of that circle first. Okay, so how I do that, it says work with a partner to locate the center of the triangle. Be prepared your strategy and your rationale. So what is the center? In order to circumscribe, we said we need to do perpendicular bisectors. So if you want to pause the video, you can. Students can have a little time. I'm just going to go ahead and do it. So if you want to leave it playing, that's okay too. I'm going to open it more than halfway, swing it out, here, in, There. Don't change my length. Yeah. Uh-oh. I think I changed it just slightly, but I think we'll be okay. Okay. So I have one perpendicular bisector. I'm going to extend it past because I want to make sure they intersect. I'm going to change colors and do the same thing on each of those sides. I'm not sure that's halfway. Let's try that. Okay. All right. I'm going to connect those lines. The line segment. All right. Now technically, I've already found it. My point is right here where these two intersect. But I'm going to do a third one just to be careful. See that they all intersect at the same place. Let me pull this up so we can see it better. Alright, did I change to green? Okay. So all I need to do is be a little bit more than halfway, so we can pull that in a little. Okay. Arc. Rotate. Arc. Over here. Arc. Rotate. Arc. Okay. So I'm going to make a straight line here, connect my two intersections, and oh, look at that perfection. Oh, that's so exciting. So when I connected those two lines, it went straight through that point that I created. Okay, so this, as you can see, is closer here, further there, further there. So we are not equidistant from the sides, we are equidistant from the vertices. So if I took this, I'm going to make a, let's say purple. Let's make a purple circle. So I'm going to go to my center. I'm going to rotate around to one of my vertices, and I'm going to say, okay, that is the distance from the center to the vertex. Now when I go all the way around, if I go and draw a circle all the way around, it should hit all three of my vertices. So let's try it. 1, 2, 3. Woo! Now I'm a little bit off. Well, I can't quite see where it is, so it's pretty close. But we have circumscribed that triangle. So we found the center is right there. Okay, so that is my circumcenter. And notice it's inside the triangle. Alright, use your compass to determine the set of all points that are equidistant from the 2 points below. Alright, so we need to find equidistant from those 2 points. Well, equidistant would be halfway, right? So really we want to bisect that. So I'm going to make a line segment just so I can see it. And we're going to bisect. So we want this again to be a little more than halfway. Arc up, rotate around, arc down. Now some of us are more comfortable just making one arc and then we see where it intersects. So every point on this line segment right here, oh, I think I just did that freehand. That was almost good. I thought I had a line tool. This is equidistant from those points, right? Any point here is going to be equidistant from A and B. That's our perpendicular bisector. All right, explain how you could modify the strategy you used above to determine the set of points that are equidistant from 3 points. Aha! So if I had another point, we want it to be equidistant here, and we want it to be equidistant there. So if we draw all 3 of those, we'll find the one place that's equidistant from all 3. All right. So construct 3 perpendicular bisectors between each pair of points. Cool. All right, so I think we have 3, 4, and 5. Let me pause real quick. Okay, So I really want you to get to the last three problems. So this we're going to work through a little quickly. It's just the same thing we just did. Use what you know about constructions to determine the location point C that is equidistant from all three vertices. So if it's equidistant from the vertices, it's kind of backwards. If I want it to be equidistant from all these vertices, I'm going to bisect the sides. If I want it to be equidistant from the sides, tomorrow we'll see I want to bisect the angles. So here I want to bisect the side, bisect the side, bisect the side, and see where that point is. What is special about point C? It is going to be equidistant from all of my vertices. So that's all the work, and I want to label that point C, right? So that is my point C. That is the center, right? It's the circumcenter. All right, do I have any writing down here? I do not. Okay, it just says use your compass to measure the distance from point C to each of the vertices. So measure that distance. Well, I know that all the radii in a circle are going to be the same distance, so technically all of those are equidistant, X, Y, and Z. All right, so what I really want to see you doing is there are three problems, 1, 2, and 3. I want you to practice finding the circumcenter and circumscribe the circle around it. And then we're going to summarize. So I want to give you some time. So if my sub could go ahead and hit pause on the video, because it's just going to keep going. So hit pause, give the students some time, maybe wander around, check and see if anybody needs help. Please, students, help each other. You guys are your best resource. You may also use the resource online if you would like. Okay. Go ahead and hit pause. Maybe with about 5 minutes left, you want to hit play again. Hopefully you heard that. Okay, so here are some answers. This is what our circumcenter looked like for the first one. For the second one, oh, that was interesting. It looks like it ended up on the triangle. And then here, it ended up outside, way outside the triangle. Okay, so let's come back together and just summarize real quickly what are all the things we looked at today. So in a triangle, the circumcenter is the intersection of the perpendicular bisectors for all three sides of the triangle. Think of it as drawing three separate perpendicular bisectors and finding where they intersect. Circumcenters are equidistant to each vertex of the triangle. They're equidistant to the vertices of that triangle. A circle that includes all vertices is called a circumscribed circle. So circum means around the outside and scribed is to write, right? We're writing around this shape. So construct a circumcenter and a circumscribed circle. Construct perpendicular bisectors on each side, find where they intersect, and then construct the circumscribed circle and place the point where the compass at the circumcenter, measure the distance to the vertex, and go all the way around. All right, notice there were three different examples we looked at. When we had an acute triangle, where all three angles were 60 degrees or less, the circumcenter was inside. When we had a right triangle, the circumcenter ended on the right, so when it was a right triangle, the circumcenter ended on that hypotenuse, and when it was an obtuse triangle, one of the angles was larger than 90 degrees, that circumcenter actually ended outside, right? Because if I wanted to get a circle, sorry, that's really bad, if it goes through all three vertices, that center needs to be way down there. All right, so what we can conclude is that if we have an acute triangle, the location of the circumcenter is going to be inside the triangle. If it's right, it's going to be on the triangle, and specifically on the hypotenuse. And then obtuse, it's inside the triangle. Actually, we were talking about this just the other day. If we have a 90 degree, oh, that does not look right. Let's try it again. If we have a right triangle, this must be the diameter, right? Because this arc is 180. For that angle to be 90 degrees, that would be 180 is the arc. Then that must be the diameter. So our circumcenter would have to be right there on the hypotenuse. All right, awesome. Well, thank you guys for continuing learning even though I was not able to be in class today. I will see you tomorrow. Thank you for my sub for helping students be successful. All right. I will post this on my MCPS classroom if you want to watch it again, or yeah, if anybody missed class, you can encourage them to watch it. Thanks for watching. All right, bye.